everyone. Hope you are fine and safe at home, and I hope that you could understood all the videos I have uploaded so far. So today we are going to discuss about the temperature dependence of resistivity. What is this temperature dependence of resistivity? Okay, already I told you that we studied that V is equal to IR, right? We studied that as we increase the voltage, the current will be increasing, taking R as constant. R is constant means you don't think like that. R will be always constant. எப்பவுமே constant இருக்கும் அப்படி நம்ம நினைக்க கூடாது. Okay. So what is R? R is nothing but it is equal to what? Rho into L by A. Okay. So this will not be always constant. இந்த value எப்பவுமே constant இருக்காது. Already discussed, right? Materials change ஆச்சுனா this value will also be changing. Okay. It will not be constant. எப்பவுமே எந்த ஒரு physical quantity எப்பவுமே constant இருக்கும் அப்படி நம்ம நினைக்க கூடாது. Physical quantity it will vary according to the situation. Okay. So now we are going to discuss how the resistance or resistivity changes when the temperature changes. Okay. When the temperature changes, resistivity la enna changes irukum? Either it decrease or increase, that we are going to study. Okay. For that we are giving the name temperature coefficient of resistance. So today we are going to discuss about two materials, that is one is conductor and the semiconductor. In both this material, what about the temperature dependence, temperature nala resistance eppadi maarudu அப்படிங்கறத we are going to discuss. Okay. So first let us discuss about the conductor. Okay. So in a conductor, we know that in a conductor, if we increase the temperature, the resistance will automatically increase. Okay. This was experimentally found. So how it is increasing? Okay, eppadi adu increase agudhu? You may have a question, right? So the reason for that increases, okay, if you take a metal, consider a metal, the reason for this increase in resistance is nothing but due to the collision. Okay, because the collision increases. How the collision getting increased? Okay, so consider a metal. Okay, so this is a metal. We know that it will be having positive charges, which is very heavy. It will not move, right? So the electrons will free to move. So when we apply the temperature, when we increase the temperature, what actually happening means these electrons are moving in this way. Okay. So in the positive charges enna pannuna light ah move agum. Okay. So usually இப்படி போய் இப்படி ஹிட் ஆகி இப்படி போய் இப்படி ஹிட் ஆகுது அப்படினா here what happens, இங்க ஒரு பாசிட்டிவ் சார்ஜ் இருக்கும், இது அதுவா போய் இங்க ஹிட் ஆகும். புரியுதா? இங்க மேபி ஒரு பாசிட்டிவ் சார்ஜ், இது அதுவா இங்க போய் இங்க ஹிட் ஆகும். So the number of collisions will be increasing. Okay. If the number of collisions is increasing, the velocity will be decreasing. Okay. Drift velocity will be decreasing, but average எல்லாம் பார்க்கும்போது it will be okay. Okay. So the number of collisions increase ஆகுறதுனால நிறைய resistance இருக்கு இல்லையா, எல்லாத்தையும் தாண்டி 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 தான் போணும். ஃப்ரீயா அதால மூவ் ஆக முடியல. Okay. It have to cross all the obstacles. So what happens? Obstacles is the resistance. Okay. So automatically our resistance getting increased. Okay. You consider a thing, that is when you are in your school, there is one steps will be there. Okay. So if I ask you to go edavadhu erangradhu inga erangu illa erradhu ipdi eru appdi, if I give an instruction, you will follow that. Okay. If it is given instruction, you can go anywhere, you can eppadi venalu eriko erangiko appdi sonna what happens? So one person he will be trying to come from here, so many will be coming from here, so many will be going there, so he had to cross all the obstacles and go, right? So the obstacles will be increasing, that is resistance increases. Okay. So I think you could understand how the resistance is increased in a metal when the temperature is increasing. Okay. Now how we have to, I told you that the increase in resistance per degree rise in temperature, அதாவது ஒரு டிகிரி செல்சியஸ் டெம்பரேச்சர் நீ அப்ளை பண்ணும்போது எவ்வளவு ரெசிஸ்டன்ஸ் இன்க்ரீஸ் ஆகுதோ that we will call it as temperature coefficient of resistance. Okay. So now we are trying to calculate the temperature coefficient of resistance for a metal. Okay. So for that, consider this metal. Okay. Consider this is a metal. Consider this is a metal. This metal is having a resistance of 1 ohm. Okay. இதுக்கு resistance 1 ohm இருக்கிறதா assume பண்ணிக்கோ. Okay. Now what you are going to do is you are going to change the temperature. Means you are going to increase the temperature. Okay. You are going to increase the temperature by 1 degree Celsius. As I already told, what happens? The resistance will be increasing. That we all know. If the resistance increases, resistivity will be increasing. Okay. Now let us discuss how to calculate the temperature coefficient of resistance. Okay, for that, so I told you that this is the metal with the resistance is equal to 1 ohm. Okay, so if I am increasing the temperature by 1 degree Celsius, எவ்வளவு degree Celsius increase பண்றேன்? 1 degree Celsius. What about my resistance? We know that it will increase. Okay, so this increase in resistance per degree rise in temperature, ஒரு degree Celsius எவ்வளவு resistance increase ஆகுதோ, that we will call it as temperature coefficient of resistance. Okay, it is designated by the letter alpha. Clear? Okay, now let us see how to calculate it. For example, please clearly you listen this. It is not in your textbook. They have just given the formula. If you listen it, it will be useful for you. Okay, so consider we are temperature 1 degree Celsius, you are increasing the temperature. Okay, so at that time what happens? Your resistance is increasing. Okay, let that increase in resistance be alpha. புரியுதா? ஒரு degree Celsius ரைஸ் பண்ணும்போது உன்னோட resistance increase ஆகுது இல்லையா? அத ஆல்ஃபான்னு எடுத்துக்கலாம். Okay, so if 1 degree Celsius it is alpha, for delta T degree Celsius what happens? Alpha into delta T. புரியுதா? ஒரு பென் வந்து 5 ரூபாய் அப்படினா 5 பென் எவ்வளவு ரூபாய்? 5 into 5. அதுதான். So 1 degree க்கு ஆல்ஃபானா delta T degree க்கு delta T into alpha. Clear? Then if we have taken 1 ohm resistance இல்லையா? இப்போ இந்த 1 ohm resistance க்கு உனக்கு change ஆகுற resistance எவ்வளவுனா delta T alpha அப்படினா 1 ohm resistance க்கு the change in resistance அதாவது increase in resistance எவ்வளவு increase ஆயிருக்குனா delta T alpha அப்படினு எடுத்துக்கிட்டோம் அப்படினா R ohm resistance க்கு what happens? R into alpha del T. புரியுதா? 1 ohm resistance க்கு alpha del T னா R ohm resistance க்கு it is R into alpha del T. Clear? Now we are going to calculate the total new resistance. Okay, already it is having a resistance of 1 ohm. Originally it is having a resistance of 1 ohm. Let us take that resistance as R0. Okay, original resistance as R0. Okay, so originally it is having a resistance of R0. Now it have increased because of the increase in temperature. The resistance have increased to R0 into alpha del T. புரியுதா? அந்த R0 க்கு கூட multiply ஆயிருக்குது இல்லையா? So we can write it as then for R0 alpha. Similarly here we can take R0. So we are writing like this. Here R0 is common. Take outside 1 plus alpha del T. Okay. So our aim is to calculate alpha. Okay. So RT by R0 equal to 1 plus alpha del T. Okay. Take alpha del T on one side and keep this to this side. So RT by R0 minus 1. Taking the LCM, RT by R0 divided by R0. Okay. So what happens? I am taking this del T to the denominator. So alpha equal to RT minus R0 by R0 del T. So what is RT minus R0? It is nothing but the change in the resistance. So I am writing it as del R. Okay. So I can write alpha equal to del R by R0 into del T. Okay. So what will be the unit of this temperature coefficient of resistance? We know that the unit of the resistance is ohm. Okay. Here also resistance ohm. What is the unit of this temperature? We can write degree Celsius. Okay. So alpha and alpha get cancelled. Sorry, ohm and ohm get cancelled. We can write the unit of temperature coefficient of resistance as per degree Celsius. That is the unit. Okay. Per degree Celsius. Okay. Hope you could understand it. Also one graph is there. I'll tell you how to identify it. So this is the temperature dependence graph of the conductor. Okay. So this is temperature and this is the resistivity. As the temperature goes on increasing, you can see the resistivity is linearly increasing. Okay. So we can say this type of materials is positive temperature coefficient materials. Okay. The temperature coefficient will be positive. Since it is increasing, we can say that materials is positive temperature coefficient materials. Okay. Clear? Next we can discuss about the semiconductors. So the next one, what happens in the semiconductor? Okay. So semiconductor means nothing but in Tamil they call it as kurai kadatti. Okay. That means semi means பாதிய conduct பண்ணோம் அப்படினு கிடையாது. In some situations it will conduct and in some situation it may not conduct. Okay. You will study elaborately in a separate unit about the semiconductors. Okay. Now Here in semiconductors, when we experimentally do, we can find out that in semiconductor, the resistivity will be decreasing. Okay, the resistance is getting decreased, so the resistivity will also be decreasing. How it get decreased? So in semiconductors, that is the reason for the current conduction of current is free electrons. Okay, so what is happening means when we heat the semiconductors means it is silicon, germanium, so many semiconductors are there. So when we heat this silicon or germanium, or when we apply temperature, so what happens means that means we know that whenever we apply temperature, atoms, that free electrons will eject out from the atom, right? So here also when we apply temperature, so what happens, the atoms will start to eject out from the atoms. அது ரொம்ப ஸ்பீடா நிறைய atoms it will start to come ejecting out from the atom. Okay, so electrons ஓட அடர்த்தி, அதாவது electrons ஓட number வந்து it will be increasing. So the reason for here the decrease of the resistance is, there I told the reason for the increase is collision. Here I am telling the number of free electron increases. Okay, இங்க என்ன ஆகும், செமிகண்டக்டர்னா அந்த அளவுக்கு free electrons இருக்காது, நார்மலா இருக்காது. ஓகே, ஆனா இப்போ நீங்க என்ன பண்றீங்க, அப்ளை பண்றதுனால நம்மளோட நம்பர் ஆஃப் ஃப்ரீ எலக்ட்ரான்ஸ் இன்க்ரீஸ் ஆகுது. ஓகே, so resistance also increases, but when compared to the number of free electrons, the resistance is less. Okay, so we can tell that here in semiconductor the resistance is getting decreased. Hope you understood it. I am telling once again, இங்க number of free electrons increase ஆகுது, ஆனா resistance increase ஆகும், but when compared to the number of electrons and the resistance ஓட, அதாவது எது ஹையர்னு பாக்கும்போது, கம்பேர் பண்ணி பாக்கும்போது அதோட, அதாவது குறைவா போறது கம்மியா இருக்கா இல்ல ஜாஸ்தியா போறதா இருக்குன்னு பாக்கும்போது, so the number of free electrons ஓட domination தான் ஜாஸ்தியா இருக்கு. ஓகே, so இதனால உங்களுக்கு என்ன சொல்ற, ரெசிஸ்டிவிட்டி கம்மி ஆகுது அப்படின்னு தான் சொல்லலாம். ஏன்னா இது ஸ்டார்ட் டு கண்டக்ட் பண்ணுது, நல்லாவே கண்டக்ட் பண்ணுது, எலக்ட்ரான்ஸ் நிறைய ஃப்ளோ ஆகுதுனால. so here we can say the resistivity reduces. In the first unit we have discussed, in the beginning of this unit we have discussed that this conductivity is equal to n e square tau by m, right? So we know that conductivity is the reciprocal of resistivity. So if you write resistivity, you can write m by n e square tau. From this also we can see that as the number of electrons increases, the resistivity will be decreasing because they are inversely proportional. So number of electrons increase ஆச்சு அப்படினா resistivity will be decrease. Okay, so in case of semiconductor, this is the graph. Okay, so what happens, as the temperature goes on increasing, we can see the resistance will be decreasing. இது increase ஆக resistance resistivity கீழ தான் வருது. Okay, so resistivity will be decreasing. Okay, hope you are clear, and I think you could understand the difference between the resistance dependence in the conductor and the semiconductor. Okay, if you have any doubt, you just ask me, and thank you for watching.